Hi everyone, this is Janine aka Janine The Tutor. As you all know, we have a lot of things going on right now. So whether you're in high school, university, and middle school, many students and families are deeply affected by the recent school closure. So as a part of OneClass, we are very fortunate that we are able to adapt quickly to this circumstance. That's why we're hosting daily classes for math and chemistry from grades 11 to first year college and chemistry. So if you're interested, make sure to check out our class schedule at oneclass.com/livestream. So in addition, we are also giving away and offering 100,000 hours of free private tutoring. So if you're interested, make sure to scroll down below and book your time slot. So for today's class, if you're from my 12 p.m. class earlier, now we're covering calculus. So I will start from limits. So for today's class, we're just doing limits for calculus, and then we'll proceed with continuity and then optimization. Actually, curve sketching first, and then optimization, and then vectors. So before we get started, just want to make sure you guys can see my screen and you can hear me coming through. Yeah, can I get a yes if you can? Yeah, so let's begin with the first question. So I know my camera is a bit, yeah, it's covering the very right side. I mean the right corner. So just bear with me, but I will read the question for you. So we have to find the slope of the tangent line to the function y is equal to 1 over square root of 7x squared minus 4 at x is equal to a using first principles, so i.e. using limits. So when they say first principles, that means you're looking for the slope of your secant, right? That's why we're taking the limit, because it's approaching x. X is approaching a in that case. So you've probably learned this in class. So we do have a formula for that. So we have limit, and you have f of x plus h minus f of x over h, right? So as you can see, you have your slope of your secant, and this is over h, and h approaching 0. Okay, so first of all, the slope of your secant is basically just this part, right? F of x plus h minus f of x over h. However, if you're taking the limit of that, that means at just one point in time, basically that's your slope for your tangent, right? So if you have the limit and then you have this, that's the slope of your tangent because it's instantaneous, right? So that's the formula, right? I'm not gonna derive f of x plus h minus f of x over h here, so we just have to apply the formula in this case because that's gonna take so much time. Cool. And also, you're also in high school, so you don't need to derive this. And it says we have x is equal to a, right? So here's the thing, because you have your function, right, which is y is equal to 1 over square root of 7x squared minus 4. Anytime you see an x, you're going to plug in x plus h, right? So that's how we're going to go and solve this question. So I'm taking the limit as h approaches 0. And there is another variation to this. So you can also use limit of x, f of x minus a. Okay, right. Minus f of x over x minus a. Sorry, this is x plus a. Yeah, so you can also use this one, but I'm going to go ahead and use h approaching 0 because I just think it's easier for you to factor. So this is just a personal preference, but if you want to, go ahead and use this. So you're going to have limit f of x plus a minus, this should be f of a, sorry. Yeah, I only use one formula, that's the thing. So f of x plus a minus f of a over x minus a. Okay, so basically, because I prefer using this formula, I'm going to go ahead and plug in x plus h. So 1 over square root of 7, and then you have x plus h squared, right? So remember, this is going to go wherever your x is. And then you have squared minus 4, right? and that's within the square root, minus whatever your function is. So you have 1 over square root of 7x squared minus 4. Okay, and then really, all you have to do is divide this with h, right? Because that's what the formula tells you. So as you can see, you have sort of a rational function here. So, sorry, not rational function, but it's a radical, right? So you have radicals here. So you can combine the two fractions, right, into one fraction. So I'm going to cross multiply. So this is what I tell my students to do. You can just do the butterfly method instead of doing the least common denominator. I think it's just easier. So, and also when you're writing the test, you're constrained with time, right? So you're going to multiply 1 times square root of 7x squared minus 4, right? And then you have to multiply this and this, right? So essentially, I'm combining two fractions into one. That's what I'm doing right now. So this is going to be 7x plus h, and this is squared minus 4. You multiply this to 7x squared minus 4, right? Okay. And then you have a negative sign here, so that means this negative sign is going to get distributed when you multiply 1 times whatever this is. So that's going to be minus 7x plus h squared minus 4. Yes, just bear with me. This is going to be a long calculation, so okay, there we go. So once we have that, right, don't forget we still have the h here at the bottom, so we're going to have an h here. So now you can see that you have radicals, right? And typically when you're taking the limit of something, right, when you plug in h, which is 0, right, when you plug in 0 over 0, you're going to get an indeterminate form. That means you don't really want an indeterminate form like 0 over 0 or infinity over infinity. That's why we want to be able to factor out your h and make sure you cancel out. So that's how we're going to solve this limit. It's through factoring. So because you have an h here, right? So you can actually multiply this to its conjugate. So what is its conjugate? So that means whenever you're dealing with radicals, that means you're going to multiply this to its opposite sign. So this would become plus. Let's see if we can fit this here. So 7x squared minus 4 okay. 7x squared minus 4 plus 7x plus h squared minus 4. And then this is over the same thing, right? 7x squared minus 4 plus 7x plus h squared minus 4. Okay, you guys can see the 4, right? At the very end. Okay. So as you can see, remember the formula a minus b times a plus b, which is what we call the difference of squares, right? So this is basically what I'm talking about. A minus b, which is this one, right? A being this term, and then you have b being this term, and then you have a plus b. So a plus b is basically the other side, right? Because you're multiplying the two. So this is a, and then you have b, and then this is a plus, right? So this is a squared minus b squared. So you call that the formula for the difference of squares, right? So you can actually say that this is going to be just a squared, right? So that means when you square this, okay, so let's just square this. What would happen to your exponent and your radical is 1/2, right? Because this radical means it's 1/2. And then when you square that, then the radical becomes gone. So as a result, you're going to get 7x squared minus 4. So let me just remove that. So this is 7x squared minus 4. So it's a squared minus, so don't forget we have the minus sign and we have to distribute that. So your b squared is simply just going to be this, right? So you're going to get rid of your radical, and then you're going to have 7x plus h squared minus 4, right? And that's it. So we can actually expand the x plus h squared, right? And don't forget, we have our denominator before we get into expansion. So h times 7x plus h squared minus 4, and then you have to multiply this to 7x squared minus 4, right? Okay. By the way, we're still taking the limit of this term, right, as h approaches 0, so I just don't want to keep writing things down, so. Okay, because I want to simplify the whole thing before we take the limit. But yeah, just to get my point across, everything is being taken when the limit of this is h approaching 0. Okay, so going back to this, so this is 1, 2, 3. So we have 7x squared minus 4, and then we can just say that this is minus 7. Let's keep the 7 inside first, and then we need to expand this, right? So this is a plus b squared, right? So that's the formula. So we're going to have x squared plus 2 times a and b, right? So 2xh plus h squared, and then you're subtracting that, right, from 4 over h, and then you have 7 times x plus h squared minus 4. By the way, if I'm going too fast, please let me know, because I know there's a lot of things going on here, so. Okay, so this is going to be multiplied to this. So I didn't really do anything in the denominator except to just copy whatever I had from the beginning. Okay, now we can expand this, right? So we can have 7x squared minus 4, right? Minus, this is now going to be negative 7x squared. And this is, let's see, minus 7 times positive 2. That's going to be minus 14xh, right? And then, actually, you know what? Maybe we can just distribute this before we have the negative sign, just so it's clear. Okay, so minus, and then we have 7x squared plus 14xh plus 7h squared minus 4, right? Because the negative sign would then affect the negative 4. Does that make sense? Okay. And then this is going to be over h, and then you have square root of 7x plus h squared minus 4 times 7x squared minus 4, right? So now we can start expanding, right? And making sure that you're distributing the negative sign to each of the terms inside your parenthesis. So, because we're running out of space, okay, I don't think we have enough space here, so I'm just going to make a new note. Okay, so this is going to be a new one. Great. Sorry. Okay, hopefully you guys can see that. Okay, let me just get rid of this. Okay, there we go. So going back to this from what we had earlier. So now we're going to expand such that we have 7x squared minus 4 minus 7x squared minus 14xh minus 7h squared, right? And this is going to be plus 4 now because the negative sign will get distributed to the negative 4, so that becomes positive 4. So as you can see, you can start canceling negative 4 and positive 4, and then also 7x squared and negative 7x squared, right? So you're actually left with negative 14xh minus 7h squared, and then that's going to be over h times 7x plus h, so nothing really changes in your denominator. Then you multiply this to 7x squared minus 4. Great. So now that we see that we can actually factor out the h, you can actually take that out, and then you're going to essentially cancel out your h in your numerator and your denominator. So this is, again, as a reminder, we're still taking the limit as h approaches 0, so don't forget about that. Okay, so where were we? So I'm going to take out h, right? So h is now taken out or factored, and then this is now going to turn into negative 14x, and this is minus, so this h would just be just 1h, so minus 7h, right? And this is now over h, right? 7x plus h squared minus 4. Then you take the square root of 7x squared minus 4. Okay, so hopefully you were able to follow until that point. Okay. So now, as you can see, we can cancel this out. And then I can just take out the 7 as well. I mean, it's not a big deal, but we can either take out the 7, but we can't really cancel anything. So we might as well just leave it like that. And then we just go ahead and take the limit now. I think we're ready to take the limit. Okay, so we have as h approaches 0, and then all you have to do is you plug in and you do direct substitution of h anytime you see direct substitution of 0 anytime you see an h. So this is minus 14x, and then you have minus 7, so this is times 0, right? So this is just going to be all gone. And then you have, let's see, negative 14. And then in your denominator, right, you're going to notice that you have, let's see, actually, before anything, I just realized that we only dealt with the numerator, which is square root of 7x squared. If you guys can see my screen. So this part, if you remember, we just basically multiplied our numerator with this, and then we forgot about our denominator. So we have just been copying our denominator throughout, and we forgot to actually deal with this part, right? Because remember, we're taking the conjugate, right? And we're multiplying that to its opposite. So in that case, we need to make sure that this is multiplied to this term, right? So now we can actually do that right here. So maybe just to distinguish that I'm doing that as well. Okay, so let's move this right here. So yeah, you guys have to be careful, especially when you're dealing with first principles. Okay, let's do that right now. So when you multiply this part, right, if you guys can see my pen, and I'm going to write this in red so everyone can see. So the denominator right here, when you multiply this to this thing, right, you're just going to have this. So you have h times this, and then this is going to be multiplied to 7x squared minus 4, and this is going to be plus square root of 7x plus h squared minus 4. There we go. Okay, so that's basically your denominator. And then, yeah, let's just carry that over until we get to the next page, because I just want to make sure everyone is following. So, okay, maybe move this here. There we go. Square root of 7x squared minus 4. And sorry, this is a plus 7x plus h squared minus 4. There we go. And then, yeah, this is just a bracket, by the way, guys. Let's move it. There. And then this one, again, is going to be the same thing. Seven x squared minus 4 plus square root of 7x plus h squared minus 4. Okay, so we can move on to this. And maybe we can just copy this. Great. So we have this thing right here. And make sure we copy this again. for the next one. Okay, I guess it doesn't want to. Okay, let's just write this again. So this is going to be multiplied to 7x squared minus 4. This is plus 7x plus h squared. And this is minus 4. Okay, there's a minus 4 there. That's part of this root. Okay, cool. Now let's see, maybe we can try something out. Okay, so if you look at your denominator right now, so you have h and then you have square root of 7x plus h squared minus 4. And then essentially you're multiplying this term. So 1, 2, 3, 4 terms, right, in total. And then we cross out the h, remember? So maybe we can see. Yeah, I'm just writing this down, so there we go. Okay, so once we take the limit, right? So for example, we're trying to figure out how we're going to deal with the denominator. So as you can see, you have this, right? So basically, you're multiplying the whole thing. So what would happen is this thing, right? You can actually combine them. So when you combine them, you're going to see that this is now going to be, let's see, minus 4, and then this. Then you have the minus 4 here. Okay. So if we try to multiply this term with this term, right? Because the goal here is basically you're going to distribute and then you're going to combine them into one term. Okay, let me just get rid of that. Okay. So, and then maybe we can take out one of the, I guess, one of the 7s here to see if we can do something. So here you have, let's take out the negative sign. So let's take out negative 7. And then you have, so once you take that out, that's 2x, right? And this is going to be plus h, right? Does that make sense? And then basically in your denominator, you're going to see that this is going to be over square root, right, of 7x squared minus 4, right? Because okay, let me just quickly do that on the side. Okay, so this is the denominator. So you have this times this, right? Which is 7x squared minus 4. And then you have to multiply this to 7x squared minus 4. And then you have plus 7x plus h squared minus 4, right? So what I'm doing is I'm distributing this to this, right? Or this to this. And then basically, so I'm doing the FOIL method in that sense. So after doing that, when you multiply 7x plus h squared minus 4 to this, you're going to see that you're having 7x plus h squared minus 4. You multiply this to 7x squared minus 4. And then from there, once you finish that, right? So this times this, so this is the first one. And then you multiply this and this. Sorry, this is a long one. And then this is the second one, right? So that's going to be plus, remember, because you have the plus sign here. And then this is going to take away that radical. So instead of being 0.5, right, this times this is going to be just 7x plus h squared minus 4, right? Does that make sense? Because it's like you're multiplying this radical to itself. So you're getting rid of that radical symbol. And then, right, after we finish 2, we're going to multiply that inner function. So this thing right here times this. So that's going to be the third one, right? So that third one is essentially this term times this term, right? So this is now going to be plus again, right? Okay, maybe I can see that. So this is first term, second term. This is now the third term. So this is now 7x squared minus 4. So that's the third term. And then the fourth term would be to multiply this and this, right? So because they're different terms, you're still going to carry that radical. So plus, because of this, 7x squared minus 4. You multiply this to 7x plus h squared minus 4, right? So as you can see, because these two are like terms, specifically 1 and 4, you can actually just add them together. You can just say that it's 1, right? And then you have 1, so when you're adding radicals, you need to keep in mind that your radicals need to be the same, and then you just add the coefficient, which is 1, so that's going to be 2, right? So you're going to simplify this. Maybe let me just highlight this here. You're going to add this and this, right? So 1 and 4, when you add them together, you're going to have 2 square root of 7x plus h squared minus 4. Does that make sense? And then make sure you still have this right here, 7x squared minus 4. And then on top of that, right, because you have this 7x plus h, right, that's going to be just squared. So this is plus 7x plus h squared minus 4, right? And let's see. Yeah, so basically you're going to add this thing and this thing, right? So we've written 7x plus h squared minus 4, and then no, actually, hold on. This is 7x squared minus 4, and this is 7x plus h squared minus 4, so you cannot add that because they're different terms. So maybe what we can do is, let's see. So we had 7, okay, so we had the h here, 7x plus h squared minus 4, this, and this. Okay, and then, let's see. Okay, let me just try to simplify things, because there's so much radicals involved, that's why. Okay, 1, this is 2, this is 3. Okay, there we go. 2, and then we have this. Okay, so for your denominator, you should really end up with, okay, so we have this thing. 7x squared minus 4, and then we have this thing. Yeah, okay, so when you expand this, right? So you have to expand this again, and then you combine this with this term, right? So this would be x squared plus, let's see, 2 xh, right? And then you have h squared, and then you multiply that to 7, and then you have the minus 4. And then when you combine this with this term, you should just end up with, so maybe we can do that. So you have 7, and then this is x squared plus 2xh plus h squared, and then you have minus 4, right? So 7x squared, and this is going to be, let's see. Sorry, I'm trying to see if my denominator is right to what I calculated initially. So this is 7x plus h squared minus 4. Because I just realized when you combine this thing and this thing, you're going to get, this is going to be positive 7x squared, and this is 7x squared. So that becomes 14x squared, which is something that we don't really want. So let's see. We have 7x plus h squared minus 4, square root of 7x squared minus 4, and then this one and this one. So when you combine the two, this is... Okay, so maybe we can start off by simplifying this term, and let's see if we're going to... Okay, let me just try this. This, and then we have the minus 4. Hold on, the minus 4... Okay, the minus 4 is actually part of the root. So yeah, maybe we can just simplify this from here. Because I think if we do expound this, x plus, this is x minus h, and this is, oh sorry, this is x plus h, and then, okay. So minus 7, 2x, and then you have h, right? And okay, denominator 7, then you have x plus h squared. Actually, you know what? Let's just plug in the h, right? Anytime you see, sorry, let's just plug in the 0 anytime you see an h, and then we just simplify that. I think that's the easiest way to go. Okay, let's do that. Great. Okay, let me just get rid of this quickly. Okay, there we go. Come on. Okay, there we go. Yeah, let's do that. Anytime you see an h, because if there's two variables, I think it's just it becomes really confusing. So plug in 0 anytime you see an h. So this is going to be gone now. So we're just going to have 0. So let's just indicate 0 here. And yeah, anytime you see an h, right? So we're starting off from here, right? So we canceled the h, and then this is going to be square root of, come on. This is 7 times x, right, plus 0, that's going to be x squared, right, minus 4, right, square root of that, and then you multiply this too, so we don't have an h here. 7x squared minus 4, and then this is going to be, yeah, so this is 7x squared plus 4, since we don't, minus 4 rather, since we don't have any h, and then this becomes 0, right, so that's going to be plus square root of 7, and then this is going to be x plus 0, so that's x squared, right, which is similar to this. X squared minus 4. There we go. Okay, so I think it's a little bit cleaner. Okay, we didn't really need to expand that. So, let's see. So we have two of them for this part. They're exactly 7x squared minus 4, so we can just say that this is 2 square root of 7x minus 4, right? So this is limit of h approaching 0. Actually, we took the limit now, so we don't really need that. So this is going to be 7, negative 7, and then you have 2x. So maybe we can combine these two first and deal with the denominator after. And so we have 2, right? And first of all, this is addition, so we're going to have 2, and then this is 7x squared minus 4, right? So once we have that, we need to multiply this to twice of this thing right here, these two terms. So that is... Okay, because it's a radical, right? So first of all, let me just clarify that this thing is this thing. Because you're adding two radicals, that's why you have 2, and then you have square root of 7x squared minus 4. And then when you multiply this, right? Maybe we can use a different color. Okay. green. Let's do green. So if you multiply this and this, because they're both radicals, right, you need to get rid of the radical because when you multiply it by itself, it just becomes 7x squared minus 4. So that's what we're going to do here. Okay, so that's the result, and that's in green. Okay, as you guys can see, we can cancel out the 2, right? And then this becomes negative 7x, negative 7x, and this is over, well, this is going to be 7x squared minus 4. Then you multiply this to 7x squared minus 4. Great. Oh, and also, guess what? You can actually simplify your root, right? Because this is negative 1/2, right? And this one is negative 1. So that means when you add the 2, you're going to get negative 3 over 2. So this can be written as negative 7x over 7x squared minus 4, because remember, they're the same base. So your exponent, when you combine the two, so 1 plus 1 over 5. So that's going to be, sorry, 1 plus 1/2, right? For your denominator, that's going to be 3 over 2. So your denominator should have 3 over 2. So that would be the slope, right? So that's slope. And what did I ask again? So they were asking for us to find the slope when it's x is equal to a, right? So all you have to do is plug in a anytime you see an x, right? So this is negative 7a, and then you have 7a squared minus 4, and then you have 3 over 2. So that's your slope when x is equal to a. Okay, that was a long one. Great. Hopefully you guys get that so far. Okay, we can move on now. Oh, and I was gonna say, I apologize that I think there was a lag a while ago. Insert that emoji with that sweat sign. So cool. We got through that, and then now we need to find the limits. Okay, so first of all, when we're trying to figure out in terms of, identifying like what is the direct way to kind of find the limits, because sometimes again you can get indeterminate forms such as 0 over 0 and infinity over infinity. What you can do is it's either you substitute or you either factor, right? So in this case, because it's x raised to the power 4 minus 256, you don't really need to substitute here because it's not like a term where you have a lot of radicals. So that's why I recommend maybe we can factor first before we even substitute, right? So if you have x raised to the power 4 minus 256, you can probably think that this can be squared, right? So such that you can say that this is x, and then you can just square this outside, and then you have, so 256, that would be 16, right? No, hold on. 16 squared is 256, yeah? But because you want to have that 2 outside, maybe we can try 4. Okay, so 4, yeah, so it works. So if you have 4, and then you have square, right? And then you square that. Yeah, 4 squared, and then you square that again. That's going to be 256, right? So you can have this, and then this is going to be over x minus 4. And the reason for that is because if you have to plug in 4 anytime you see an x, you're going to get 0 over 0, right? So that's what we don't want to run into. That's why we're doing this. So as you can see, you have a squared minus b squared. So all you have to do is make sure you have your denominator written down, and then you can just say this is x squared minus 16, right? Because this is 16. So a plus b, a minus b essentially. So this is that, and then you have x squared plus 16. There we go. Okay, so we have that. And then x squared minus 16, again, this is difference of perfect squares. So this is x plus 4 and x minus 4, right? And then you multiply this to x squared plus 16. Maybe I can just write that down below. There. By the way, this is coming from this part, right? And this is, so we use, or we applied the difference of perfect squares, and then we have the x squared plus 16, right? So we're going to have that here. And then this is going to be over x minus 4, right? As you can see, we can cancel out x minus 4, and then we get x plus 4 times x squared plus 16, right? So limit, now we take the limit. As x approaches 4, you're going to have x plus 4, then you multiply this to x squared plus 16, and then you're ready to just simply use direct substitution. So 4 plus 4, that's 8, and then you have this 16 plus 16, right? Okay, so 8, and then you have 16 plus 16, that's 256. So your limit for this function is 256. Great. Do you guys have any questions so far? I just wanted to know, so far, how has everyone been doing? And for the people who just came in recently, I just wanted to say hi. Welcome. Okay, great. So we can move on to this question. Okay, so whenever we're dealing with absolute values and you need to take the limit, you need to break it down into piecewise functions, right? So what is piecewise functions? So when you break this down into piecewise functions, you're going to have a negative sign out here, and then you have x minus 3, right? So this absolute value sign becomes a bracket or parenthesis, and then you have x minus 3, and then this is going to be over x minus 3, like whatever you have here, right? And then on the other hand, you're looking at x minus 3, and it's positive over x minus 3. Does that make sense? So the reason why we need to have a negative sign right here, it's because if you're dealing with absolute values, right? Remember, if you draw the graph of square root of x, no, sorry, not square root of x, absolute value of x, which is equal to y, that's our function. So you do have, so let's see. If you draw this like this, right? If you think about the template function or the parent function, you're dealing with the negative values as well, right? In an absolute value. It's not simply just this side, right? You have x approaching 3 from the left, and that's coming from here. On the other hand, you also have, let's say, 3 coming from the right side. So that's why you need to have piecewise functions whenever you're dealing with the limits of absolute values. And then you need to specify that you're looking at x when it's greater than 3, which is coming from the right side. And then you have, I guess this is your left now, but this is my right. So you're coming from the right side. That's why it's x greater than 3. And then you have the left side, which is x less than 3. Does that make sense? Okay, let's put a comma there. So that means you're only dealing with this part because you're specifically looking at 3 plus, which is coming from the right side, right? So x minus 3 divided by x minus 3 is equal to 1. So when you take the limit of, it's 1, right? So you're taking the limit of x minus 3 over x minus 3. As x approaches 3 from the right, this is equal to 1. That's why the limit of this function is 1. Cool. Okay, so we have another one right here. Okay, so this is what I want you to do for now. Take your calculator and punch in 7 punch in 7 anytime you see an x, right? So make sure you have square root of 9 plus 7 minus 4 over square root of 7 plus 2 minus 3, right? Okay, so that's what I'm going to do right now. So 9 plus 7 minus 4 divided by 7 plus 2, and then that's minus 3. Just make sure the negative 4 and the negative 3 are not part of your root. Okay, so you're going to see that it's going to be, so 9 plus 7, that's 4 minus 4, so that's 0 over 0, right? So this is what you call an indeterminate form, and you don't really want that. Okay, that's not the way to go, right? So if it's an indeterminate form, you need to obviously make some modifications, right, in order to find the limit. So this is the time that you should be using substitution because you see radicals, right? Typically, anytime you see radicals, substitution needs to be involved. Or you either multiply it to its conjugate, but I've tried that, so I'm telling you right now, in your own time, when you multiply this by its conjugate, right? For example, you want to get rid of the denominator. If you multiply this with square root of x plus 2 minus 3, you're still going to get 0 over 0. That's why I did substitution for this question. Or maybe it will be doing substitution in that case. So we can start off with our numerator, right? So we have square root of 9 plus x. So maybe I can just write that here. This is going to be a long question, just so you know. So we can just say let u, right, be equal to any variable equal to square root of 9 plus x. And then basically we want to find what x is, right? So we can say that this is u squared, and this is equal to, first of all, why is it u squared? Because I can just take the square, right, so to get rid of this radical, and then you have 9 plus x, right? So u squared minus 9 is equal to x. Okay, so next up, we have square root of x plus 2. Because it's different, right? It's not the same thing as this one. We can just say, maybe we can just use w. So w is square root of x plus 2. Okay, so when you have to square this, right, to get rid of this radical, you're going to have w squared, which is equal to x plus 2. Makes sense? Because when you square this, that gets rid of the radical. Because 1/2, right? This radical means it's 1/2, so the exponent times 2 becomes 1. Clear? Okay, so again, we're going to isolate x, right? So w squared minus 2, which is equal to x, right? So now that we have that, right, we can actually equate u squared minus 9, and that's going to be equal to w squared minus 2, right? So maybe I can quickly highlight that. So we're going to equate this and this. I mean, because they're the same thing, right? They're equal to x. So u squared minus 9 is equal to w squared minus 2. Okay, so because we want to apply substitution here, that means if you look at your numerator, right? So we said this was going to be square root of 9 plus x, and then this is square root of x plus 2, right? If we isolate u, right? So first of all, why are we isolating u? Because I'm focused on the numerator for now. So you have to isolate just u. So you're going to have u squared is equal to w squared. And then when you move the negative 9 to the opposite side of the equation, you're going to get 7, right? Because it's 9 minus 2, which is plus 7. And then as a result, you need to take the square root, right? And then you're going to have u and then square root of w squared plus 7. Okay, you're probably wondering right now, didn't you just substitute so that you can get rid of the radical? Well, yes, but here's the thing. I'm going to show you what will happen if we're taking this square root of w squared plus 7 and replacing that with 9 plus x, right? And why is it this square root of 9 plus x? Because that's what u stands for, right? It's square root of 9 plus x. So that's going to replace that, and we're still taking the limit, just so you know. As, well, this is going to change now because x is not approaching 7 anymore. We're using w. So all you have to do is plug in 7 anytime you see an x, right? In this equation specifically. So you're going to take square root of 7 plus 2, and that's going to be equal to 3, right? So when x is approaching 7, maybe we can just write that here. Let's use a different one. Okay, so when x is approaching 7, that means you take this equation, you're going to say that you have w is equal to, so 7 plus 2, that's going to be equal to 3, right? So we can actually say that this is w approaching 3. Cool. Okay, so let's proceed with the denominator. So the denominator, we have square root of x plus 2 right here. But since, remember, it's square root of x plus 2, right, which is w, and because we want to keep the same variable throughout this equation, so we can just say this is w, right? Simple as that. And then we have w minus 3. Okay, so once we have that, we have reduced the number of radicals in our function, right? So in that case, that's the whole point of using substitution, because we want to reduce the number of radicals. We're not trying to complicate things by introducing more variables and having more radicals. We want to reduce the number of radicals so we can deal with this better. So this is the time you're going to apply conjugate multiplication, meaning you're going to multiply this whole thing with its opposite sign. So this is w squared plus 7, and this is plus 4. And then you're going to do the exact same thing in your denominator, which is w squared plus 7 plus 4, right? As you can see, remember the a minus b, a plus b. So this was a squared minus b squared, right? Again, you're still taking the limit, but let me just simplify this. So in this case, you can just say that this is w squared, right, plus 7. So that's a squared minus b squared. So minus b squared, that would be 16, right? Negative 16. This is over w minus 3. Then you multiply this to square root of w squared plus 7 plus 4, right? Is that clear so far? Okay, so 7 minus 6 is 7 minus 16 is actually negative 9, right? So we have w squared minus 9. And then this is going to be w minus 3. And then this is square root of w squared plus 7. Just keep in mind that the 4 is not part of the root. Okay, there we go. And then from there, right, we can actually apply your difference of perfect squares again. Okay. So you know how this is you know how this is w squared minus 9? You can just say that this is w plus 3 minus, and then you have w minus 3, right? So you can actually get rid of the w minus 3 in your denominator. There we go. And now that gets rid of the indeterminate symbol. So w squared, and this is plus 7, and this is plus 4 outside. There we go. Okay, now we're ready to take the limit. So if you take the limit as w approaches 3, and then you have w plus 3 over square root of w squared plus 7 plus 4. So when you apply direct substitution, in this case, you're going to see that your numerator is actually 6, right? Because 3 plus 3 is 6. And then your denominator, let's try to plug that into your calculator. So you take the square root of w squared, so that's going to be 9 plus 7, so that's 16, square root of 16, and that's going to be 4 plus 4, which is 8, right? So as you can see, this is going to be 6 over 8, and then 6 divided by 8 is equal to 3 over 4, right? So your limit is 3 over 4. So that's for part C, right? The limit of part C is 3 over 4. Great. So because we still have enough time to go over one more question, let's just get through this. Or maybe if we can get through until part E before we even go to number 3. So bear with me, we're almost there. Okay. What I'll do, I don't think this is going to fit here, so maybe we can just continue from the other page that we started. Okay, hopefully you guys can see this. I'm just going to scroll down and... Sorry, let me get rid of this first. Okay, I guess it didn't copy. Okay, hold on. 1 second. Okay, so yeah, let's begin with this question. So we have u raised to the power of 3 over 4 minus 64 over u minus 256. Yeah, so anytime you see, again, this is like a radical again. It's just that they didn't explicitly say that this is u cubed and then you have 4, right? But this is a radical. So what you can do is substitution, right? Or Actually, yeah, you can only use substitution here because if you have u raised to the power of 3 over 4, you can actually say that this is, let's start with u and 3 over 4. So we can say let u, and this is going to be equal to, let's say, a variable, right? And then in your numerator, you see that this is u, and then you have 3 over 4, right? And this is going to be w, and then this is going to be raised to an exponent, right? So in this case, you're going to think of sort of like a common factor that you need to multiply 3 over 4 so that you get an exponent, right? Such that you can just use one of your variable, which is w, and then the goal here is to eliminate the 3 over 4 because you want to have a whole number as your exponent, right? So the best number here, if you have 3 over 4, this would need to be 9, right? Okay, come on. There we go. This would be 9. And then on top of that, if you have u here, right, that means this needs to be 12, right? So w, and this is 12, right? So this is when u is raised to the power of 1, and then you get w raised to the power of 12. And then on the other hand, so all you have to do anytime you see a u, that would be replace, right? So this is w9 minus 64, and then you have over, so that would be w12 minus 256, right? Does that make sense, guys? So let's double check. 3 over 4. Okay, and by the way, just so you're wondering, you know how this was u raised to the power of 3 over 4? You're probably wondering, so where did you get the 9 exactly? So because you have 3 over 4 here, all you need is you multiply this 3 over 4. Because remember, this is 1, right? So if you're turning u1 into w12, okay, when I say u1, that means raised to the power of 1, okay, just so to remain consistent. And then you have w, which is raised to the power of 12. So basically, you need to think about how can you turn this, right, into w12 when you have 3 over 4. So this is sort of like a ratio here. So if you have 1, right, 1 times 3 over 4, right, is going to be 3 over 4, right? That means when you have 12, right, if you want to get to 9, you need to multiply 12. So try this. 12 times 3 over 4, you should get 9, right? Because when you simplify this, this is going to be 3 and this is 1. So 3 times 3 is 9. And then you're going to see that this should be w9. So that's how I was able to identify what the factor is in order to multiply. So again, this is a ratio thing. Okay, so we have w9 minus 64, and this is over w12 minus 256, right? So maybe we can try to simplify this further. Again, you're taking the limit, but now it's w approaching another value. So maybe we can try this one right here. Actually, let's use a different color just so it's not confusing. Okay. I'm going to use a green pen. Okay, so w... Oh, I don't think you guys can see this. Okay, I'm going to use this equation right here, and I will figure out what w is. Because you're using substitution now, the variables become different. That's why I'm finding or looking what w is when I'm replacing u. Does that make sense? Because otherwise I wouldn't really need to do the step, but because we're substituting, you need to change 256. So we said 256 was u, and that's equal to w raised to the power of 12, right? So in order to just have w, you need to take the square root of w. Well, it's not square root, it's the root of 12, right? Sorry, root of 12. So you take the root of 12, and then you have w, which is equal to the root of 12, and then that's 256. There we go. Okay, so once we have that, you're now going to think about how you're going to factor w9 minus 64. So if we tried having w cubed, okay, w cube, and then you have to cube this again, and then this is going to be minus, let's see, 64. That would be 4, right? So 4 and, no, but that's just cube. So yeah, so 3 would be the best one because you can't really have 2. So, I mean, 4 would be the best one right here. So this is going to be inside, right? So that would be 4 raised to the power of 3, and then this is going to be over, right? So what would happen in your denominator is maybe if you can try to split this into square, because remember we have the a squared minus b squared, maybe we can just use that. So we're going to have w, 6 is inside, and then we're going to have square minus 16, right? 16 times 16 is 256. So 16 squared, and that's going to be inside, and then you have square, right? Okay, we're ready to solve this. So just as a quick recap, as you can see, you have a cubed minus b cubed, right? So a cubed minus b cubed. So difference of cubes, right? We have this formula a minus b. First of all, how do you know this is minus? If this is minus, this has to be minus. And then you multiply this to a squared plus ab plus b squared, right? And then on the other hand, if you're adding this, if this is addition, this has to be addition and this has to be minus. So that's how you remember your formulas, because it would be crazy if you don't have a trend to remember. Okay, yeah, that was just my opinion. So here, a squared minus b squared, this is a plus b, a minus b, so we can deal with that. So this would now be, let's see, so this is w cubed, right? So whatever's inside, because it's a, so this whole thing, w cube is a cube, right? I mean, it's a, and then you have a cube, which is this cube, and then you have this cube, right, which is minus 4. And then from there, you multiply this to a squared, right? So what's your a? Your a is w cubed, right? Right, so that's going to be w raised to the power of 6. And then plus ab, so that would be plus, a is 4, sorry, a is w cubed, so that's going to be 4w cubed, right? Because your b is this. And then you have plus b squared, which is 16. And that's going to be over w6. So a plus b, a minus b. So you have 16. And then you have w6 minus 16, right? Okay. Then, let's see. W cubed. Okay, that's what we have right now so far. W6 plus 16, and then you have W6 minus 16. Okay, so we can actually break this down further, right? Into 2, right? When you raise this as an exponent of 2. That's what I meant. W cubed minus 4, and then you have W raised to the power of 6 plus 4W cubed plus 16. And this is going to be over W6 plus 16. And then what you can do, you can just say that this is going to be W raised to the power of 3, and this is going to be squared, right? Minus, we can say this is 4, and then you have square, right? So a squared minus b squared, right? So this is now going to be W cubed minus 4 W cubed plus 4. So you can cancel this and you can cancel this, and you're left with this numerator and the denominator at the bottom. So this is W6 plus 4W. This is cubed, not squared. Plus 16. And this is going to be over W6 plus 16 times W cubed plus 4. Right? So now we're ready to take the limit. So the limit, you need to plug in square root of 12. Sorry, not square root. Why do I keep saying square root? Root of 12 when you have 256, right? So limit as W approaches this, and then you have W6 plus 4W cubed plus 16, and then you have W6 plus 16. And because you're only looking for the limit, you don't really need to simplify things further. You just have to plug in this value in this, right? So when you do that, let's see. Yeah, when you do that, you're going to get 3 over 16, right? So try this in your calculator. So plug in 12, right? So root of 12, and you have 256 inside. And then basically you're going to raise that to the power of 6, right? And then, yeah, try this now. So plug that into your calculator, and then this is going to be plus 4, and then make sure you have that parenthesis. So that's cube, sorry, not cube, but 12, and then you have 256. Then you raise this to the exponent of 3 plus 16. And then in your denominator, you're going to see that you have another w raised to the power of 6 here. So that's going to be 12, and then you have 256. And this is raised to the power of 6 plus 16. Make sure you have another bracket to multiply that to w cubed plus 4. So w cubed, that would be root of 12. And then you have 256 plus 4. Okay, so you should be getting, let's see, 3 over 16 as a result when you plug that into your calculator. Okay, so for the next class, we'll just continue